dimensional lattice. Okay, where we have one atom at per unit cell. Okay, जो एक लैटिस पे हमारे पास एक एटम था. Now we are going to consider a case where we have two atoms per lattice point. Okay, for example, suppose you have a gallium arsenide one dimensional lattice. Okay, indium phosphide, or say you have similar silicon or germanium. Okay, which have two atoms per unit per lattice points. Okay, and then for example you have a polymer chain. So in this polymer chain both the atoms are same. Okay, but since the bonding is different, okay, bonding of two neighboring atoms are different, so we can consider these two atoms are different. Okay, so if we have two atoms per unit cell or per lattice point, for example, say this is a heavier atom, mass is m1, this is a lighter atom, mass is m2, then we have another lighter atom, again we have a heavier atom. Okay, so this is my m1, this is m2, okay, this is m1. Okay, so this is small, and again we have a heavier atom. Okay, say the distance between the two atoms is a by 2. Okay, so this total distance is a. So I'm considering this is a one point. This is a one point. Okay, but एक lattice point पे दो atom है. Okay, in that condition how the dispersion relation will be. हमने one dimension का dispersion relation already देख लिया, ओमेगा और के में relation क्या है. अब अगर टू एटम पर lattice point पे आ जाएंगे तो हमारा dispersion relation कैसे vary करेगा. Okay, so say this is my heavier atom. So heavier atom I'm representing by 2n. Heavier atoms I'm representing by 2n even number. Okay, because there are two atoms. Earlier I was representing by atom nth atom. Now because there are two atoms एक point पे, so say this is 2n atom, and lighter atom by odd atom. See this is 2n plus 1. Say this is 2n plus 2. Okay, so this is again 2n plus 3. Say this is this is 2n plus.
हमने 2n और लिखा हुआ है, वहाँ 2 एटम्स होंगे, मतलब
ऐसा नहीं है. हमारे पास लैटिस में n एटम तो बड़े वाले हैं, n एटम छोटे वाले हैं. ओके, तो मैं जो हैवियर एटम है उसको मैं बोल रहा हूँ इवन एटम है. जैसे फर्स्ट एटम है वो हमारा लाइट एटम है, सेकंड एटम है हमारा वो हैवियर एटम है, फिर थर्ड एटम हमारा फिर लाइट है, फिर फोर्थ एटम हमारा बड़ा वाला है. तो ऐसे ही जहां भी नंबरिंग आएगी तो मैं बोल रहा हूँ कि जो हैवी एटम है वो 2n है, वो इवन नंबर है. क्लियर?
ओके सर, फिर हम 2 एटम्स पर लैटिस पॉइंट ये कैसा है, मतलब एक लैटिस पॉइंट पे दो,
एक ये वो नियर बाय है. एक लैटिस पॉइंट पे 2 एटम्स है. सो ये जैसे पहले एक एटम था, अभी 2 एटम है, पास में है, बॉन्ड है उनके पास में. ठीक है, सो दिस इज 2n minus 3. Now say we are giving extension to this 2n plus 1, so this will get extend. The extension will be u2n. Okay, similarly the extension of this will be u2n plus 1. Okay, similarly the extension of this one will be u, like we done last case, 2n minus 1. Okay, so assume these are springs.
Sir,
these bonds are springs. Yes.
So the number of bigger and smaller atoms are same.
Yes.
Okay, sir.
Okay, so this is, say these are the springs. Now we are assuming all the springs are same. Okay, now I want to calculate the force on this 2n atom. I want to calculate the force on heavy atom. Okay, as well as I want to calculate the force on light atom. Okay, तो अगर heavy atom पे मुझे force का equation लिखना है F2n, how can I write? कैसे लिखेंगे? F2n is m d2u 2n upon dt square. Okay, like we have written last time. If I want to write the force, so there will be two forces. Okay, one will be beta if the spring constant is beta. okay, the force will be what? क्या force होगा?
So beta 2n plus 1 minus 2n minus 1.
Okay, you're giving full expression. I'm writing first components. Okay, one force will be this direction. Okay, so since the extension of this spring is to u is in the x direction is u2n plus 1, and similarly this spring is coming with un distance here. Okay, so the net extension in this spring will be u2n plus 1 minus u2n. Okay, similarly there will be force on this atom in minus x direction due to this atom. Okay, and that we can write, how can we write? We can write u2n minus u2n minus 1. Okay, so if I write the force equation, this will be u2n plus 1, okay, plus u2n minus 1, and this will be minus beta, so 2u2n. okay, so जैसे हमने लास्ट टाइम दिखा था, जिस भी एटम पे फोर्स निकालना है, ओके, वो एटम माइनस में आ जाएगा 2 ट्वाइस होके, उसका जो एक्सटेंशन है, एम्पलीट्यूड है, वो माइनस में आ जाएगा ट्वाइस होके, और आगे वाला 2n plus 1 u एंड पिछला वाला u2n minus 1. ओके, सो दिस इज द फोर्स इक्वेशन ऑफ मास 2n, ओके, ऑफ मास m1, okay, or 2n atoms. Okay, 2n atom पे क्या force लग रहा है, that will be given by this equation. Okay, similarly I can write the mass on force on lighter atom. Okay, so lighter atom I'm saying representing by m2. Okay, so m2 is less than m2 is less than m1. Okay, you can also represent m2 by small m also. So m2 is lighter atom. So if I want to write the force on a lighter atom similar way, I can write beta. Okay, क्या लिखूं उसके लिए? क्या लिखूं?
u2n plus 2 minus u2n plus 1.
u2n plus 2. Okay, then
plus
u2n minus
u2n plus 1.
un plus 1. Okay, okay, so this will be your, say, equation 1. These are the force का जो इक्वेशन है हमने लिख लिया है. ओके, नाउ सेम वे आई विल राइट द ट्रेवलिंग वेव सॉल्यूशन फॉर दिस लैटिस. इसको मिटा दूं क्या ऊपर वाले को?
Yes, sir.
ओके, so now I am writing traveling wave solution. तो जो heavier atom है उनका amplitude को मैं I am representing by 2n. okay, amplitude is a, and so I can write e iota kx minus omega t. okay, omega t minus kx. so kx is what for another atom? x की वैल्यू कितनी है?
2n
2 and a by 2. lattice constant a था ना, मैंने a by 2 बोला था, तो वापस n आ जाएगा. you can write lattice constant as a 2a also. so I am representing lattice constant by a. okay, a by 2 distance. so it is your choice, you can write both the way. okay, so this will be your u2n. okay, and u2n plus 1 क्या आ जाएगा? I am writing b iota omega t. okay, k 2n plus 1. okay, a by 2. now both the atoms are different, okay, but they are moving with same frequency. okay, so I am not changing the frequency, I am only changing their amplitude, because one is heavy, one is lighter. so when they are doing motion, okay, what will happen? Their amplitude will vary. so for heavier atoms or lighter atoms, I'm writing amplitude b. for heavier atom, I'm writing the amplitude is a. okay, now you can substitute these values in these equations. okay, so wherever is even, you use this equation. Wherever is odd, you have to use this equation. so if you substitute this value, you can write the expression for f1 and f2. okay, so write the expression for f1 and f2. So suppose if I want to write the expression for f1, okay, so दिस इज m d2u 2n upon dt स्क्वायर, तो इसको डिफरेंशिएट करेंगे तो दिस विल गिव मी m1 omega square a, okay, and then beta u 2n plus 1. So this term will come, so beta b iota k a by 2 plus iota minus ki by 2, okay, minus 2 beta a. ये आ रहा क्या फर्स्ट इक्वेशन? इफ यू यूज दिस वन, ओके, इसको डिफरेंशिएट करेंगे तो ये आएगा m1 ओमेगा स्क्वायर है, आइटा ओमेगा सेम आ जाएगा, डिफरेंशिएट करने पे एक्सपोनेंशियल तो सेम ही आएगा, तो a ओमेगा स्क्वायर माइनस आइटा ओमेगा का स्क्वायर और मास है m1. दिस इक्वेशन विल बी बीटा b आइटा k by 2 प्लस माइनस आइटा k by 2 minus 2 बीटा a. ओके, सबका आ रहा है?
Sir, why are we taking traveling wave solution?
So wave is traveling, na? There's a wave, so you have to write traveling solutions. Last class also we done, if it is a wave, so wave is iota kx omega t, iota kx minus omega t. That type of solution I'm trying here.
Yeah, but how can we get you get standing wave solution or something like that?
Standing wave, last time we have seen if the lattice is fixed. Okay, here I have not shown you the lattice is fixed. Okay, this was long infinite lattice. Okay,
So it's infinite lattice.
So we're assuming there will be. So now similarly, if I write equation for this one, m2 omega square b, if I'm taking this equation, if I solve this one, this will give me minus m2 omega square beta a, okay, e power minus iota k by 2 plus minus iota k by 2, okay, minus 2 beta b. Okay, both are symmetrical equations. Okay, so now if I solve these two equations, okay, so let me rearrange these equations. So this I can write as a cos 2 cos a by 2. So if I rearrange this equation, I can write this 2 beta, okay, 2 beta minus omega square m1, okay, as a coefficient of amplitude a minus 2 beta, okay, cos k by 2. Okay, this is an easy calculation, you can do it later also. Okay, if you're not able to understand now, okay, this is very easy calculation. Okay, so this is this is my equation say. So similarly, if I rearrange this equation, okay, I can write minus 2 beta cos k by 2 a, okay, plus 2 beta, okay, minus omega square m2 b equals to 0. Okay, so let us say this is my equation second. Now these are linear equation, okay, in a and b. So we need to solve this equation and we have to calculate the dispersion relation. So इसको रब कर दूं क्या ऊपर वाले को?
Yes, sir.
Yes, sir.
Now if we solve this equation, okay, please solve this equation a and b, 2 beta minus omega square m1, okay. Similarly, here will be minus 2. Am I audible?
Yes, sir.
Okay,
Sir, recording.
Recording. Okay, so this will be minus 2 beta cos k by 2. Okay, similarly here minus the coefficient is minus 2 beta cos k by 2. Okay, the coefficient of b is 2 beta minus omega square m2 equals to 0. So solve this determinate, so you'll get the relation between omega and k. So if you solve this equation, what we'll get? 2 beta minus omega square m1 into 2 beta omega square m2. Okay, similarly if you multiply this one, this will give me plus 4 beta square cos square k by 2. Okay, so if we solve this equation, this will give me omega 4. Okay, omega 4 m1 m2. Okay, similarly if I multiply this by this term with this term, okay, so this will give me minus 2 beta, okay, omega square m1 plus m2. This term will give me omega square m1 2 beta, so 2 beta will be common. This will give me m1 plus m2. Okay,
Sir, omega squared.
and omega, this term there will be omega square, and this will give me 4 beta square. Okay, 4 beta square, okay, 1 minus cos square k by 2 equals to 0. So now this is the quality equation in omega square. Okay, so I can write omega 4 is equal to 2 beta m1 plus m2 divided by m1 upon m2 omega square, okay, plus, okay, 4 beta square m1 upon m2 1 minus cos square k by 2 equals to 0. Now if I write the solution of this equation, so solution of this equation, you can write this as a sin square k by 2. Okay, so I'm writing here sin square k by 2, sin square k by 2. So now the solution of this equation will be omega square, okay, that will be what, minus b by 2a plus under root b square minus 4ac upon 2a type of solution will be there. Okay, so here, so omega square, so there will be plus minus, so I'm writing here plus minus, so this will be plus minus square equal to minus b. So minus b is your 2 beta m1 plus m2 upon m1 m2, okay, 2 beta by 2a. Okay, so coefficient of a, omega for a is 1, divide by 2. Okay, this will be beta. Similarly plus minus b square, so b square will be, now this will be 4 beta square m1 plus m2 ka square, and we have m1 m2 ka square, okay, minus 4ac 4, okay, 4a is 1 and c is this, so this becomes 16. So 16, okay, beta square m1 m2 sin square k by 2. okay, करेक्ट है, ठीक चल रहा है अभी?
Yes, sir.
Yes, sir.
Okay, so and 2a, this
Sir, by
2a,
2.
this 2a by 2, okay, this by 2 also. So if we solve further, this will give me plus minus square beta m1 plus m2 upon m1 m2. okay, so इसमें से 4 कॉमन ले ले, बीटा भी कॉमन आ जाएगा. So okay, so this will be plus minus, we take 4 out. okay, so 4 आगे 2 बार 2 आगे 2 से तो कैंसिल हो जाएगा, so it will be beta. okay, so beta m1 plus m2, okay, upon m1 m2 का whole square. okay, and there here we will have minus 4 beta square, okay, m1 m2. yes
Beta squared we have taken common.
हाँ, बीटा को बाहर से बाहर कॉमन रखें तो बाहर बीटा आ जाएगा. ठीक है, 4 भी निकाल
हाँ,
लिया,
तो बीटा स्क्वायर
4 भी निकाल लिया हमने.
हाँ,
वो
बीटा
आया
स्क्वायर नहीं होगा ना उधर.
क्यों?
सेकंड टर्म में, नीचे सेकंड टर्म में.
सेकंड में बीटा स्क्वायर है ना इधर.
नीचे
हाँ सॉरी, ये वाला. ठीक है, तो अभी मैं इसको 4 लिख रहा हूँ. ठीक है, 4. सो 4 में से 2 को मैं अंदर दे रहा हूँ, 2 sin स्क्वायर k by 2 मैं इसको वापस लिख देता हूँ cos के टर्म में. तो ना वी हैव दिस इज माइनस cos k. ओके, ऐसे लिख सकते हैं ना, 2 m1 m2 cos a. ठीक है, सो दिस विल बी 2. ओके, करेक्ट है ये. सो नाउ बीटा, ओके, m1 plus m2, Okay, I'm solving a little bit further. Okay, so this is actually your expression. This is your expression for omega. Okay, plus is, now we have two branches. Plus is
सर ये 2 how you have written sir 14
हाँ।
बीटा स्क्वायर तो 4 तो पूरा बाहर आ जाएगा ना 2 में 2 2
हाँ,
कैंसिल हो 2
हाँ।
कैसे आया
अरे भाई यहाँ 16 है ना,
हाँ तो 4 बीटा स्क्वायर
तो
होगा वो
4 बाहर आ गया था, 4 बीटा स्क्वायर बाहर आ गया था, तो यहाँ
हाँ
4 तो बचेगा ही ना। 4 में से 2 इधर दे दिया, 2 sin स्क्वायर,
अच्छा
इसको मैंने cos
अच्छा
1 1 cos लिख दिया।
ओके सर
ठीक है, सो नाउ इफ यू सॉल्व इट फर्दर, I'm simplifying further ताकि इसको याद करना आसान हो जाए. This will be omega square plus minus beta m1 plus m2 m1 m2. Okay, so this will be plus minus beta. अब m1 plus m2 upon m1 minus m2 इसको ही बाहर निकाल लो. So this will come as a m1 plus m2 m1 m2, ये बाहर आ जाएगा. तो अंदर क्या बच जाएगा हमारे पास में, दिस विल बी 1 अंडर रूट में, दिस विल बी 1 माइनस, ओके, माइनस ये टर्म आएगा m1 m2, इसको कॉमन निकाल रहे हैं तो क्या आ जाएगा 2 m1 m2, ओके, और m1 प्लस m2 का होल स्क्वायर, ओके, इनटू 1 माइनस कॉस के. ठीक है, ये ऐसा लिख सकते हैं ना.
Yes, sir.
Okay.
Yes.
Okay. So now if you carefully see this term, अगर इस टर्म को हम देखें, ओके, तो ये टर्म पॉजिटिव, ये जो टर्म है वो लेस देन 1 है. कैसे? इफ आई सी 1 माइनस कॉस ए, 1 माइनस कॉस के, ओके, इसकी वैल्यू क्या होती है, या अगर ये 1 है तो ये पूरा 0 हो जाएगा, ओके, और ये अगर 0 है तो ये टर्म क्या हो जाएगा. तो 1 माइनस कॉस ए क्या है, क्या आएगा 1 माइनस कॉस ए, 1 माइनस कॉस ए, 1 माइनस
0
कॉस ए,
to
2 सॉरी 2, ओके, सो
-1 हो सकता है.
हाँ 2, ओके, सो दिस विल बी बिटवीन, दिस टर्म विल बी between 0 to 2, okay. So suppose now I want to write this 2m1 m2 m1 plus m2 का square, okay, 1 minus cos ka, okay. So when 1 minus cos a is 0, so this whole term is 0, okay, so this whole term is 0, okay, and when 1 minus cos 2 is 2, okay, the maximum value of this term is what, 4 m1 m2 m1 plus m2 का whole square. Can I write like this?
Yes,
Okay.
sir.
Okay, now this 4 m1 m2 m1 plus m2, this is less than equal to 1. For example, if I take m1 equal to 5, m2 equal to 5, so 5 25 into 100, 5 plus 5 10 100, okay, maximum value 1. If m1 and m2 are different, okay, for example this is 2, this is example 3, so 2 into 3 6, okay, 2 into 3 6 24, 2 plus 3 5 25, okay.
N is greater than or equal to GM.
Will be
Arithmetic greater than equal to geometry.
so suppose this is 2 and 3 6 24 and 25, so this will be, this value will be always less than 1. And doubt, is this expression is correct or not?
Yes, sir. Yes, sir.
Yes.
Okay, so this value is always less than 1. That means this term is positive, you are not getting any complex number, okay. So now that means we have omega's two values, okay, with one with plus, one with minus. So now can I write can I wrap this one?
Yes, sir.
Okay, now I want to write what is omega plus, okay. So if I want to write omega plus, so omega plus will be, omega plus 1 square will be beta m1 m2 m1 m2, okay, plus beta m1 plus m2 m1 m2, okay, under root 1 minus 2 m1 m2 m1 plus m2 का square 1 minus cos ka. Okay. Now I want to see this value of this branch. Okay. अगर ये क्योंकि ये प्लस है, ये हायर फ्रीक्वेंसी है. ओके, so generally we say this is the optical branch. Okay, and when is there a minus, we say this is the acoustic branch. So now for each k value we have two frequency value. For each k we have two frequency value. That means now we have two branches. In the case of linear lattice, we are having only one branch. Okay, that was acoustic branch. So we'll see further. So how to analyze, how to
Sir,
हाँ बोलो.
so plus sign denotes higher values of
हाँ,
omega.
because ये प्लस है ना यहाँ पे, तो ये हायर फ्रीक्वेंसी ब्रांच. ओके, माइनस विथ लोअर फ्रीक्वेंसी ब्रांच. नाउ आई वांट टू सी what is the value of omega plus at k is equal to 0. So if I put a at k is equal to 0, okay, if I put k 0, so what will happen? This term will become 0. So what will the value of omega plus 1 square? Let me know what will the value if k is equal to 0. Okay, so this term will be 1.
m1 m2 upon.
So this will be 2 beta. Okay, m1 plus m2. Okay, m1 upon m2. Okay, and you can also write 2 beta 1 upon m1 plus 1 upon m2. So if I want omega plus, this will be under root 2 beta 1 by m1 plus 1 by m2. Okay, so this is at k is equal to 0. Now similarly, if I want to write the value at k is equal to plus minus pi by a, so what will be the value of this omega plus branch? So if I want to calculate at k equal to plus minus a, तो ये वैल्यू क्या हो जाएगी? प्लस माइनस पाई बाय ए पे
-2.
2. Okay, so I can write omega plus square beta m1 plus m2 m1 plus m2. Okay, beta. Okay, m1 plus m2 m1 m2. Okay, so this will become under root 1 minus 2 m1 m2 4. Okay, this becomes 4 m1 m2 upon m1 plus m2 का square. Okay, so solve it further. So इसको अगर और आगे solve करेंगे, so what will become? So this will become beta m1 plus m2 m1 m2. Okay, plus beta m1 plus m2 m1 m2. Okay, इसको करेंगे तो क्या हो जाएगा? ये m1 minus m2 का होल स्क्वायर नहीं हो जाएगा?
यस सर.
ओके, तो खोलेंगे तो क्या हो जाएगा? ये m1 minus m2 upon m1 plus m2. So okay, is this correct? Okay, mistake हुई है.
करेक्ट करेंगे तो सिंपल कैंसिल हो जाएगा.
करेक्ट है? तो अगर इसको मैं काट दूं इसको. ओके, सो नाउ व्हाट विल हैव? यू हैव बीटा. ओके, वी हैव बीटा m1 plus m2. okay, and plus m1 minus m2 upon m1 m2. okay, m2 cancel. Okay, 2 m1. okay, so m1 we cancel, this become 2 beta m2. 2 beta m2. okay, so that is lighter atom. So now I can write at k equal omega plus value is under root 2 beta upon m2. okay, so I am writing this value at one corner. Okay, we'll use this value. So at k is equal to 0, I have omega plus is 2 beta 1 upon m1 plus 1 by m2. okay, similarly we have at k is equal to plus minus pi by a, I have omega plus is equal to 2 beta upon m2. okay, so these are the the value of lower branch, okay, acoustic branch for k is equal to 0 and k is equal to plus minus a. Okay, so for
Optical
k is optical branch already, the higher branch is optical branch. Okay, the plus branch is optical branch. Now I'm writing for acoustic branch. Lower branch is acoustic branch. Okay,
now you're right. So this basically means the optical branch frequency will be between root 2 beta by m2 and root 2 beta into 1 by m1 plus 1 by m2, right?
you're not audible. What did you say?
I said the frequency of the optical branch will be between omega plus equal to root 2 beta by m2 and root 2 beta into 1 by
We'll see. We'll plot a graph now. We'll see what is the range for optical and acoustic.
Sir,
Okay.
just please tell the definitions again. Optical branch and acoustic branch. What do you mean?
So the higher branch, what we are denoting on that omega plus, that is your optical branch. Okay, and the lower branch is omega minus, that is we are mentioning by acoustic branch. Okay, what is the meaning of these things? Okay, why do call one is optical branch, why do call one is acoustic branch? So we'll see later. Okay, let me derive this thing and then we'll quality try to understand what is the meaning of these branches. Okay.
Okay, sir.
Okay, so now acoustic branch. Okay, acoustic branch means, now what are the expression we were having? Okay, so omega minus square, it will be beta m1 plus m2. Okay, m1 m2. Okay, minus, what are the expression? One, what are the expression for this one? This was
Same, just minus sign here.
common, it was common. 1 minus 2 m1 m2. Okay, m1 plus m2 का square and 1 minus cos k. Okay, 1 minus cos k. Okay, so this is your acoustic branch. Now I want limiting value at k is equal to 0 and k is equal to plus minus pi by a. Okay, so at k is equal to 0. Okay, at k is equal to 0. Okay, what will happen? This is become 1 0. Okay, and this becomes 0. So omega minus square is 0. Okay, so omega minus is 0 at k is equal to 0. Okay, similarly I want to see at k is equal to plus minus pi by a. Okay, so what will it become? Minus omega square beta m1 plus m2 m1 upon m2. Okay, okay, so this is 1 minus, okay, 1 minus 1. Okay, this become 1 minus again 4 m1 m2. Okay, m1 plus m2 का square. So if you solve it, पहले से सॉल्व करना सेम. ओके, बस यहाँ पे माइनस से प्लस की जगह तो थोड़ा सा फर्क आएगा. बीटा m1 plus m2 m1 m2. okay, this will become now what? 1 minus m1 minus m2 m1 plus m2. Okay, so this become beta m1 plus m2 m1 m2. Okay, this become m1 plus m2 minus m1 plus m2 and m1 plus m2. Okay, so this time कौन सा माइनस हो रहा है? m. Okay, this is minus m1 माइनस हो रहा है ना, और यहाँ से this is sorry, यहाँ पे कुछ मिस्टेक हुआ है. is correct? सही चल रहा है क्या? Okay, this will be beta m1 m2 m1 m2. Okay, so here we have 2 m2 m1 plus m2 का स्क्वायर तो नहीं है. Okay, so m1 m2 कैंसिल हो गया. Okay, and then m2 भी also cancel हो गया. So we have 2 beta m1. Okay, so I can write at k is equal to plus minus pi by a. Okay, my omega minus value is under root 2 beta upon m1. Okay, so m1 is my heavier atom. Okay, so now let me draw the dispersion curve. ये ठीक है क्या? अभी आगे चलें, इसको मिटाते हैं।
सर मिटाइएगा मत।
हाँ, so 2 beta m1, okay, 2 beta m2.
So this means acoustic branch frequency is always less than optical branch frequency.
Acoustic branch is always less than, okay. Optical, as the name suggests, no, optical frequencies are generally
Yeah,
higher than acoustic, okay.
Acoustic means has to do with sound waves, like
Sound like sound waves, okay. और optical भी यहाँ पर what we mean optical here only up to infrared only, not UV visible or UV light, okay. So all the vibration we are producing in the lattice, they are mechanical, they are not electromagnetic waves, okay. Don't confuse, these are I'm writing name optical, that is electromagnetic wave, okay. These are all mechanical vibrations, because lattice vibrations are always acoustic vibration, okay. Only optical branch is slightly higher than acoustic branch, and that can be activated using light, okay, infrared lights, okay. That's why we are giving, because they are higher branch, we are giving the name of optical branch, okay. For example, if you have a crystal of NaCl, okay, so they are charged at atoms, okay. So that can be influenced by electric field of light. So and that can be done up to higher frequency, up to, okay. So that's why we are giving that optical branch. Let me draw the graph now. So इसको मिटा दो क्या सबको?
Yes, sir.
Okay.
सर NaCl के लिए जो स्टेटमेंट आपने बोला सर, और एक बार
हाँ, अभी जो प्लॉट करता हूँ उसको अभी इसका मीनिंग है, अभी काफी लंबा चलेगा, ठीक है ना. तो दिस इज okay. So now let me plot this graph, okay, for k. Roughly we know what is the graph, okay. We don't know exact expressions, okay, but roughly we know what is value at minus pi by a, and what is the value at plus pi by a, okay, and what is the value at, okay, omega frequency value at k. So we have seen for optical branch, okay, the value is at k is equal to 0, the value is 2 beta. So and here the value is 2 beta m2, okay. So this will be, so around k is equal to almost near to k is equal to 0, okay. So near to k is equal to 0, this optical branch is almost constant. यहाँ पे एकदम constant है. This value is almost constant in this region, okay. And the value is what? The value is under root 2 beta 1 upon m1 plus 1 by m2, okay. And this value is what? This value is under root 2 beta m2, under root 2 beta m2, okay. Similarly, if we see acoustic branch, okay, so this is your optical branch, okay. Similarly, if you see your acoustic branch, okay, that has a k is equal to 0, that is 0, okay, and there's 2 beta upon m1, okay. So this will be 2 beta upon m1 and 2 beta upon m1, okay. So we know m1 is greater than m2, m1 is greater than m2, so obviously this point will be below of this point, okay, क्योंकि ज़्यादा है 2 beta m1 ज़्यादा है, this point will be low, okay. And this region, okay, so this region is your what? This region is your forbidden region, okay, forbidden region, okay. So that means in this region you cannot excite your crystal, okay, if the frequency in this range, okay. Now let us quickly see some qualitative statement of this graphs, okay, okay. So इसको मैं रब कर रहा हूँ, we have already drawn here. So now let us say if m1 equal to m2, okay, if m1 is equal to m2, then what will happen?
No forbidden region.
Okay, so this point will be same, this point will be same, okay. So there will be no forbidden region. no forbidden reason. Okay.
So the acoustic
Huh.
branch curve should be smooth, right? And
Hmm?
should not be that nudge, right? The JEST
That we'll see. We are discussing. Na? Let me discuss one point by point. Okay. So if M1 is M2, okay, there's no forbidden reason. पर ब्रांच से तो अगर M1 इक्वल टू M2 हो गया तो सब कुछ सेम ही हो गया ना, वापस लीनियर लैटिस नहीं हो गया क्या?
Yes, sir.
वापस लीनियर लैटिस हो गया.
Yes, sir.
But still we have two branches. So that's point I want to clear. It's not if M1 is M2, you say this is a linear lattice. Okay. Here the thing is there should be two atoms. Both can be equal mass. There should be two atoms per lattice point. That is a difference between the monoatomic lattice and diatomic lattice. Okay. So even though if the masses are same, okay, but still you'll get optical branch. If there is a two lattice point, two atoms per lattice point, still you'll get both acoustic and optical branch, both you'll get. Okay. Now, so if I say point number 2, okay, if M2 is infinite, if say M2 is very large, M2 is infinite, in that case what will happen? If M2 is infinite,
Zero.
Sir, you are saying M2 infinite in comparison to M1.
Sorry, M1. You say if M1 is infinite, okay. If M1 is infinite, heavy mass is infinite, then what will happen?
Forbidden zone बड़ा हो जाएगा.
If M1 is infinite, okay, so this point will become what? 2 beta upon M2, like same thing.
There will be no acoustic branch.
Sir,
First, let me discuss this optical branch, then we'll come to acoustic branch. Okay, is M1 is infinite, okay, very large compared to M2. Okay, so I can neglect this term and I will get again 2 beta M2. That means this become what? Constant.
Yes,
Okay. This ये क्या हो जाएगा? नीचे जाएगा, इधर आ जाएगा, दोनों सेम हो जाएंगे ना सारा. तो this will become flat. Okay, if M2 is M2 this become flat, and if this is infinite, okay, so this become what? 0. So you have this one, acoustic branch. So you have no acoustic branch. Okay, the frequency of acoustic branch becomes 0. Okay, and you have only optical frequency. That means your crystal is now vibrating with what? A constant frequency. If out of two M1 M2, one is very large, okay, if M1 is infinite, okay, then your atom will be vibrating. Okay, so all atoms, of course your heavy atom will not vibrate, because if the atom amplitude is very high, okay, so that amplitude will be negligible, 0. So other lighter atoms, all lighter atoms will be vibrate. Okay, all atoms vibrate with same frequency. Okay, that is what? That is equal to 2 beta upon M2. Okay, or 2 beta, you can write small m, that is lighter weight. If you write M2 equal to lighter atom weight, M2 equal to M lighter. So this is the assumption which Einstein used, okay, while explaining the specific heat of solids. Okay, so what was the difference between Einstein and Debye? Einstein says that all the atoms solid, they are vibrating with same frequency. So he was referring this assumption. Okay, so this is the second case. Now let me discuss that what is optical and acoustic branch. Okay, why do call it one is optical, one is okay. And one more thing, if I told you if M1 equal to M2, okay, so what will become? This become this gap will become 0. Okay, and if M1 is equal to M2, this become 4 beta M. Okay, if M1 is M2, this become the maximum frequency will become what? 0 to under root 4 beta M. Okay, so there will be two frequencies from 0 to under root 2 beta M. That will be your acoustic branch, and from 2 beta M to under root 4 beta M, that will be your optical branch. Okay, now shall I rub this one?
Yes, sir.
इट इज पॉइंट क्लियर ना भी? अगर ये दोनों एक पॉइंट हो जाएंगे तो 0 से 2 बीटा एम, ओके, ये तो आपका हो जाएगा अकॉस्टिक, और 2 बीटा टू 4 बीटा, ओके, 2 बीटा टू 4 बीटा एम, दैट विल बी योर द फ्रीक्वेंसी रेंज ऑफ योर ऑप्टिकल ब्रांच, ओके। तो इसको रब कर दूं मैं?
Yes, sir.
ओके,
Sir,
हाँ,
if you're saying M1 infinite, so it means in comparison to M2, or means
you're
infinite
not audible.
M1 means what? Hello?
Hello,
Hello? Am I audible now?
शिवेश,
Yes, sir. Am I audible now?
am I audible? ओके,
Yes, sir. You,
Yes, sir. Yes,
ये
sir.
आवाज आ रही है क्या?
Yes, sir. Yes, sir.
मेरी
Shivesh
आवाज
was asking why your
मेरी वॉइस आ रही है मेरी?
Yes, sir.
Our voice is
सतीश,
हेलो
Yes, sir.
सर को
सतीश मेरी वॉइस आ रही है?
आ रही है सर।
सर को हमारा आवाज नहीं जा रहा है सर। Well, I think M1 is infinite means just M1 is very.
You've seen, we have seen the equation of A, amplitude A and B, okay. We have seen the equation of A and B, okay. I have written, I think, equation number 2, okay. Now I want to solve that equation, B by A ratio, okay. I want to calculate what is the B by A ratio, okay, for both acoustic and acoustic as well as your optical branch, okay. So if I say beta plus A, okay, that I can write, I can use any there was 2 equations, okay, in equation number 2, so you can use in either equation. So I'm writing and I'm taking second equation, so I can write m1 upon 2 beta cos k by 2, okay. So earlier we were having these 2 equations when we are writing amplitude, okay. So we were having these equations, 2 beta omega square m1 A, okay, 2 beta cos k by 2 b equals to 0, and we are having 2 beta cos k by 2 a, okay, plus 2 beta minus omega square m2 b equals to 0, okay. We are having 2 equations, so I am taking now beta b by a, okay, using this equation, okay. So this will become 2 beta b by a, okay. So b upon a 2 beta omega square m1, okay, this first equation I'm taking, okay. You can use second equation also. So now I want to see how this equation b by a equation changes when you go from acoustic to your optical branch, okay. So first I want to see the b by a relation for acoustic branch, okay. So for acoustic branch, okay. So for acoustic branch, I know at k is equal to 0 near, I want to see how this dispersion relation changes, okay, or how this dispersion relation behave at near k is equal to 0. So for acoustic branch, say let k tends to 0. So when k tends to 0, I know my omega plus, acoustic branch omega minus, okay, omega minus is 0. So if I calculate b by a for my acoustic branch, okay, this will give me what, 2 beta, and when k tends to 0, this cos tends to 1, okay. So I'll get 2 beta upon 2 beta, 2 beta upon 2 beta, that is 1, okay. That means near k is equal to 0, okay, my both the atoms have same amplitude, okay. That means for acoustic branch near k tends to 0, both the atoms, okay, both the atoms have same magnitude and phase, same magnitude and phase, okay. So both the atoms are vibrating like we have done in a monoatomic crystal, okay. They both are moving in same direction, okay, either this direction or this direction, and their amplitude also same and phase is also same, okay. Similarly, if I want to calculate, okay, if I want to calculate this expression b by a, okay, b upon a for optical branch. Okay, so
Sir,
BA,
how do I know phase is same?
because the B by A sign is same, na? Amplitude B by A.
Okay,
B and R both are amplitudes. Okay, so they magnitude also same, phase also same. Okay, so now similarly, if I want to write this for optical branch, okay, so optical branch. Okay, so B by A. Okay, so put the value here. So 2 beta. Okay, M1. I write omega plus square. Okay, 2 beta cos k by 2. Okay, now if I want to write B A, okay, plus, now near k tends to 0. Okay, so k tends to 0 region. K tends to 0 region. K tends to 0 region. So if k tends to 0 region, okay, so k tends to 0 region, we have W omega plus. Okay, value is what? 2 beta 1 upon m1 plus m2. Okay, so you can write 2 beta minus m1. Okay, this value is 2 beta. Okay, 2 beta 1 by 2 beta 1 by m1 plus 1 by m2. इसको मिटा दूं क्या? इसको मिटा दो.
Yes, sir.
Okay. So if I write this 2 beta 2 beta cos k by 2. Okay, so solve this one. So this will give me 2 beta, okay, minus 2 beta, okay, m1, okay, 1 upon m1 plus 1 upon m2. Okay, and this is 2 beta. So in k is equal to 0, this becomes 1. Cos k become 1, which is k tends to 0. Your cos k by 2 is 1. Okay, so I can write this is also 2 beta. Okay, so if you solve it further, this give me 2 beta minus 2 beta. Okay, so this will give me this m1 m2. So m1 plus m2. Okay, m1 cancel हो जाएगा तो ये आ जाएगा m2. Okay, upon 2 beta. And if you solve further, this will give me 2 beta m2 minus 2 beta m1 minus 2 beta.
So 2 beta हम cancel कर सकते हैं.
हाँ, 2 beta. Okay, so 2 beta cancel हो जाएगा. सॉरी 2 बीटा कैंसिल हो जाएगा और नीचे क्या m2 भी तो आएगा m2. ओके, सो m2, सो 2 बीटा कैंसिल हो जाएगा. ओके, सिमिलरली m2 कैंसिल हो जाएगा. सो दिस विल गिव मी व्हाट? माइनस m1 अपॉन m2. ओके, so that means my b by a ratio for optical branch, okay, this will be what? Minus m2 m1 upon m2. Okay, so I told you that b is what? B is the amplitude of a lighter atom. Okay, and a is the amplitude of heavier atom. So amplitude of atom is inversely proportional to their mass. Okay, so b is proportional to 1 minus m2, a is proportional to 1 minus inversely proportional to 1 minus m1. Okay, and there is a minus sign also there. Okay, so what it suggests, okay, that
Out of phase.
they both are out of phase. Okay, so they are out of phase. Okay, so that means both are vibrating, okay, with respect to their center of mass. While in acoustic branch, your center of mass is vibrating. Here these two masses are vibrating, okay, out of phase. That means that motion is with respect to your center of mass. Okay, so if I want to represent what is optical phonon and acoustic phonon, okay, so how can we represent? This is near k by 0. Okay, so already in monoatomic crystal also we have seen that near k is equal to 0 we form standing waves. Okay, similarly here we will see if I want to represent, so what will be? So I can represent my optical phonon. Okay, so say this is my 0 line, this is a heavier atom. Okay, 1 2, 4, 5. So this is 6, 7, 8, 9. Okay, so these are heavier atoms. Okay, so these are heavier atoms. Okay, and similarly, if I want to write my lighter atoms, okay, so this is one atom, this is 1, 2, 3. Okay, so similarly here 1, 4, 5. Okay, I'm sorry, one will come here, one. Okay, this is one come here. Okay, so these are heavy atoms, these are light atoms. Okay, that means your heavier atoms. Okay, say this is mass m1, this is mass m2. Okay, mass, you say mass m2 or you say small m, mass m. Okay, so both are vibrating in out of phase. Okay, so this is your optical mode. This is your optical mode. Okay, while if we see your acoustic mode, okay, so in acoustic mode, what is happening? Your 2, 3, 4, 5. 1, 2, 3, 4. Okay, so you are all lighter. Okay, light atoms as well as your heavier atoms. Okay, they all are vibrating in one phase. Okay, so this is your acoustic branch. This is your acoustic mode. Okay, so
Sir, in the optical case, the
one minute.
curve should be more steep, right?
Which curve are you talking about? This one?
In the optical, no, in the left side, the first.
This one.
Yeah, the optical in the light for the lighter atoms, as the amplitude is larger, so it should be more steep curve, right? I mean,
that you can draw. Okay, I have not drawn that this accurately. Okay, so
okay.
so now there are many still some quality discussion we have to do. Okay, so today I'm stopping class here. Tomorrow we'll further try to understand what are these optical mode and acoustic mode. Okay, so here I want to say one thing. Okay, the frequency, generally the frequency of this optical mode is near IR regions. Okay, so if any crystal, okay, if there are two atom and one lattice point, so there will be always optical branch. Okay, along with this acoustic branch, you'll get always you'll get optical branch. Okay, now again when we see from 1D to 2D or 3D crystal, what is the exact number of these modes? Okay, कितनी acoustic branch होती है, कितनी optical होती है, तो optical में भी longitudinal कितनी होती है और दूसरी वाली कितनी होती है, those all description. Okay, I will discuss tomorrow. Okay, so
Sir, so acoustic phase is same, that is why you have drawn
they're
same
thing. Okay,
and their optics, they are out of phase, that is why you have drawn sinusoidal type.
yes ये भी sinusoidal है, इसका फेज अपोजिट डायरेक्शन में, ये ऐसे मूव कर रहा है, ये ऐसे मूव कर रहा है. ठीक है, ये वो दोनों एक ही फेज में मूव कर रहे हैं.
Okay, sir. And so you have used the word phonons. तो phonons, what is the relation of phonons?
ये जैसे लैटिस वाइब्रेशन को ही फोनॉन बोलते हैं ना. जैसे आपका लाइट होती है, लाइट का जैसे लैटिस वाइब्रेशन की भी तो एनर्जी है ना. लैटिस वाइब्रेशन भी तो एक मोड, दूसरा मोड, तीसरा मोड. So all the lattice vibration, their energy is quantized, like same like your electromagnetic waves energy is quantized. Okay, similarly your lattice vibration energy is also quantized, और इस quantized इसको फोनॉन बोलते हैं. So lattice vibration को generally we call it phonon vibration. Okay.
Okay, sir.
Okay.
Okay, thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.